Welcome back, pre-calculus students. We're going to take a look at now something called the intermediate value theorem. This is frequently abbreviated IVT. What it says is that given P is a polynomial with real coefficients, if P of A and P of B have opposite signs, there's at least one C value between A and B such that P of C equals 0. That's kind of crazy, I know, but it really kind of intuitively makes sense once you get a feel for it. What it's saying is this. Let's say here's an A value, and let's say here's a B value somewhere along our x-axis. And we have some polynomial. It looks, I don't know, kind of looks crazy, maybe basic, something like that, though. And that's what P of x is on the interval from A to B. P of A, in this case, is negative. P of B is positive. Because these things have opposite signs, one's positive, one's negative, it could have been negative, positive, positive, negative, it doesn't matter. What is important is that they're opposite signs. We know that some point in here has to equal 0. We're going to call this C and say that P of C equals 0. That's what the intermediate value theorem says. That if you're changing y value signs, one's going from positive to negative, there exists some x somewhere between A and B in which you're going to equal 0. Again, it's pretty basic, it's pretty straightforward, it's intuitive, but the wording could just be a little confusing. Use the intermediate value theorem to show that g of x, which is negative 3x cubed minus 5x plus 12, has at least one 0 between negative 3 and positive 1. Okay, so let's figure out what the values are. If g of negative 3 and g of positive 1 have different signs, we know that there's a 0 in between them. That's what the intermediate value theorem says. So let's plug it in. Negative 3 times negative 3 cubed minus 5 times negative 3 plus 12. Negative 3 equals negative 3 cubed, that gives us negative 27, times negative 3 gives us 81, plus 15 plus 12 equals, that's 81 plus 27, which is 108. Even if it's not 108, I know for a fact that thing is going to be positive. Oh, okay. Before I go on to G and 1, I'll make this change now. I made this change on my notes, but I forgot to write it here when I started filling it out. That should be minus 12. That should be minus 12, which makes G of negative 3 minus 12. Which makes that 97, which makes that 82. 84, excuse me, 84. Okay, now we're looking at G of 1. G of 1 will be negative 3 times 1 cubed minus 5 times 1 minus 12. That's negative 3 minus 5 minus 12, which equals negative 20. Okay, so what's happening is, even if we don't know what this graph looks like, G of negative 3 is positive 84, G of positive 1 is negative 20, so somewhere in here there has to exist some 0. And that's what the intermediate value theorem says. So show that there's at least one 0 between these two values. It's guaranteed because we have a sign change. That's it. That's all we have to do. It's not asking for what the 0 is, it's just saying show that there is one using the intermediate value theorem.